Okay, hello everyone. So apparently REPL.it isn't working correctly for me today. So I'll be using my personal editor. I'll be using Vim. So just be wary, the commands you'll see me use, they'll be different on your computer, but the code that I'll be writing should be the same if you write it on REPL or anything else. So let's get started. I'm going to move this away. And I'm going to introduce today's topic. So, today we're going to be talking about linked lists. So, what is a linked list? A linked list is a different way to represent a Python list. So in Python, we can easily declare a list like this. We do L, or anything actually. It can be XL, list, list equals brackets, or square brackets, square brackets, and anything we want to be in this list. For example, we can have 10, 20, 30, 40, anything we want, and we can append elements to this list. We can do list dot append like 44, and if we run, and if we run file.py, it will append that. It won't print it because I keep forgetting to print the list. But if we run this, so it will append that, and this should be old news by now. You should know how lists work. If you don't, then I really recommend you listen to the past lesson. I think Pranav did lists, so you should check in the video channel on our Discord, and you can watch the video on lists. But today's video is about linked lists. So a linked list, instead of looking like this, looks a bit like this. So we have the value, for example 10, and we have a special box here, which is the next element in the list. For example, to represent this list, in the linked list, we would have this 20. What? Okay, 40. And this doesn't point to anything, so it's just like this. This is how we would represent a linked list. Instead of doing this, we do this. This code actually won't run if we try to. If I get rid of this and I try to run this code, it will run, of course, because I commented it out, but it won't actually compile, because this is just a way of thinking about how linked lists work. And in order to have actually a functioning linked list, we have to implement it ourselves. So let's actually do just that. First, let's make a node class. I'll make a constructor. This, you should be familiar with this if you watched our episode on object-oriented programming. If not, just check it out, because we'll be doing a lot of object-oriented programming in this lesson. Okay, so now I'm going to declare self.value, assign it to value, self.next, assign it to next. Okay, and also, just so I can easily print it out, I'll make a print node function, which will just be printing self.value. Okay, that's our node class done. Basically what we did so far is just create the infrastructure to be able to store things like this. And we can actually represent a linked list just with this. We can create a node right here, value of 10, and next will be none. I'll name this node 1. And node 2, I'll make it node 20 and none as well. And now I'm going to edit this to be node 2. So this is kind of what a linked list is. Oh yeah, of course. This is what a linked list is. It's basically a connection between objects. Basically, if we visualize this, it's basically 20, no, it's actually 10, which connects to node 20, like this. That's basically what this is. But it's pretty hard to just manually add them and just add none and node 2 if we want that. That's kind of complicated. So instead of doing that, we'll create a new class called linked list, like this. And same thing, a constructor here. And I'll set self head equals none. Now what this is, I'll put a space here. Self head. This will be our first index of our list. So in this case, self.head will be 10. Will be actually this node right here. And we need to know the head to be able to access any other element in this list. Okay, now I'm going to make a few functions. They'll be empty for now, but I'll fill them out as we go. So pushback. So value, pass. By the way, if you don't know, pass basically means do nothing in Python. So just pass, do nothing. Push, front. I'll explain what these do later. Just need to pull them out for now. Into that. Okay, so these are all the functions that our linked list will have. I'll start with pushback, so we can get an idea of how linked lists work. And then I think I'll fill out print list so we can actually see what's happening in our list. Okay, so pushback. What this function will do, it will push, it will basically append an element to the end of the list. It's basically equal. It's basically an equivalent to list.append. That's basically what it is. I don't know the exact function for push front, but push front basically just does append, but instead of appending to the end of the list, it appends it to the front of the list. So I'll explain that later after I do this. Oops. So first, let's create a variable called temp head, and I'll set this to self.head. And this will act as our as a variable that we can move around without actually disturbing the real head. Yeah. So then we will loop over until head.next is none. But we just write it in a different way. And then each time we do that, we do, oh, not head, temp head. Each time we do that, we set temp head to temp head dot next. And then after that, we do temp head dot next equals node value and then none. Yeah, because we push it to the end. So we create this temporary variable right here, and while temp.next isn't none, so basically this goes all the way to the end of the list. Temp head is the next. Yeah, it just moves the head, the temporary head, all over to the end of the list, and then it sets the next of the temp head to value none. Now this will actually work if we sorry. This will actually work if we have multiple elements in our list, but if we have 0 element in the list, it will break. So we'll just do this. If self.head equals none, then we'll set self.head equals node value none, and then just return. Okay. So this should be working right now, but before I run this, I want to create the print list so we can see what's happening. Okay, so I'll do the same thing. I'll just create a new temp head variable and set it to self.head. And while temp head isn't none, so it goes to the end of the list, we just print. No, we don't actually print. We do temp head dot print like this, and then we just like move temp head over by 1. Okay, so now we should be ready to run this list. First, I'll delete all of this, and I'll create a new linked list. A new linked list object, and let's push back the value 10, and then I'll just print the contents of this list. Okay, let's see. Moment of truth. Python 3 file.py. Is this file.py? Yeah. Okay, so it does actually work. It prints out 10, and we can actually do this multiple times. If I just yank this line, and then I do this, and then change this. You can actually change this to whatever you want. And let me just change this to random numbers to show that we're actually moving. Oh, this is not a good example. Okay. And as you can see, it pushes them like this. It just pushes them in the list. I believe this, the beginning, that's the, this is the head, and this is the end of the list. So if we were to represent this list, it would be like this. We would have 10, 21, 12, 16, 23, and that's it. Yeah. So you get the point here. This is basically the next. This is the next variable, and this is value. Okay. So now let's get push front working. Push front is actually very easy. It's actually the easiest between all of them, because all we have to do in push front is create a temp head as well. Oh, actually, we have to create a temp head in almost all of these, and set it to self.head. Then self.head equals node value head. Oh, sorry, temp head. Temp. Huh. Okay, yeah, sorry, this is weird. I think this is how it's supposed to be. In my notes, I have it set to just temp head, but let's try this. It might not work. And also, one thing I know is we have to do the same thing we did here, actually. I'll just copy it. Okay, let's try this. Okay, yeah, yeah, and this should work. Let's test this. Let's add a new node, push front, and I'll do 1. And this should go all the way to the top of our input here. Yep, and it works. It's at the top of the input even if we pushed it all the way here. Okay, so that works. Now, the last one, which I'm going to show you, is insert at. And this is probably the most complicated one. Actually, it's not that much harder than pushback, but... Okay, so we create a temp head as well. To sub.head. And then we loop forward between 0 and the index here. And then we move it all over. We do temp head equals temp head dot next. Same thing, except same thing as pushback, except we only loop until the index. So we only go over to the index. And then and then we do temp head dot next equals node value, and then temp head dot next. And we can test this again. Let's do this. Yeah. Dot insert at, and the value I'll insert 100 so it's easy to see. And let me insert it. This is 1. Let me insert it here. So, okay. It should work. Is it saying an error? Oh, that's just a bug. Okay, so it works. I think it's... Yeah, I think it's just a problem here. But it works, and you could probably tweak this a bit to work the way you want it to work. Yeah. This is probably not the way to optimize it, but there you go. 0, 1, 2, 3. Yeah, okay, it works now. So just make sure to use -1, your index there. So this is about it. This is all there is. I'm going to zoom out a bit so you can see the code from like an overview. As a recap, this is the node class. Basically, what a linked list is, it's just a connection between node objects. Sub.next is just another node. It's the next node in the list. So I hope you guys learned something. And goodbye.